Present here. I'm Ramya Devi, working as assistant professor in SNS College of Engineering. Today I'm going to share a small article regarding machine learning. So machine learning is a branch of artificial intelligence that focuses on building algorithms and models that allows computers to learn from data, make predictions and improve over time without being explicitly programmed. There are three primary types of machine learning. One is supervised learning. The model is trained on labeled data, meaning the input data is paired with the correct output. The algorithm learns to map the inputs to the outputs and generalize from the data. Common tasks include classification and regression. Example, predicting house prices based on features. And next is the unsupervised learning. The model is trained on data without labels. The goal is to identify hidden patterns or structures in the data. This can involve tasks like clustering, grouping similar data points, and dimensionality reduction, simplifying data. Common algorithms include k-means clustering and principal component analysis. Next is reinforcement learning. The model learns by interacting with its environment and receiving feedback in the form of rewards or penalties. The aim is to find an optimal policy that maximizes cumulative reward over time. It's commonly used in applications like robotics, game playing, example AlphaGo, and autonomous driving. Machine learning has a broad range of applications including natural language processing, computer vision recommendations, and predictive analytics. So, supervised learning can be further divided into two types. One is classification, the other one is regression. Classification is used when output variable is categorical. Example, with two or more classes like yes or no, male or female, true or false. Regression is used when the output variable is a real or continuous value. In this case, there is a relationship between two or more variables. So there are types of supervised learning algorithm: linear regression, logistic regression, naive-Bayes classifiers, decision trees, random forest, support vector machines. So next is unsupervised learning. So unsupervised learning can be further grouped into two types. One is clustering, the other one is association. And the clustering is the method of dividing the objects into clusters that are similar between them and are dissimilar to the objects belonging to another cluster. It is grouping of data based on similarity. For example, finding out which customers made similar product purchases. Association is a rule-based machine learning to discover the probability of the co-occurrence of items in a collection. For example, finding out which products were purchased together. The most commonly used unsupervised learning algorithm is k-means clustering, hierarchical clustering, a priori algorithm, and principal component analysis. So the next is the reinforcement learning. Reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of action. For each good action, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. And the types of reinforcement learning is Q learning and SARSA, state action reward state action. So the Q learning is basically the type of reinforcement learning in which it learns from the environment, and it is a type of reinforcement learning used to find the optimal action selection policy for a given environment. The goal of Q learning is to learn a policy that maximizes the total cumulative reward over time by interacting with an environment and updating the value of actions on the rewards received. The key concepts in Q learning is agent, the entity that interacts with the environment and makes decision. Example, a robot, a game player. Environment, the external system that agent interacts with. A grid world, a game, or any system that provides feedback to the agent. And next, the state, a specific configuration of the environment that the agent can observe at a given time. Action, the set of possible decisions that agent can make at any given state. And next is the reward, a numerical value representing the feedback the agent receives after performing an action in a state. The goal is to maximize cumulative rewards. Next is Q value, a value that represents the expected future reward for taking action A in state and then following the optimal policy. Q values are stored in a Q table, a strategy the agent uses to determine the next action to take based on the current state. Next is the learning rate, determines how much the Q value should influence the existing value. And next is the discount factor, how much the agent values future rewards versus immediate rewards. A high value means the agent prioritizes long term rewards.